Yeah, and a spacecraft in this environment is charging up. If you imagine, it's maybe similar to someone walking on rubber shoes on a surface, and suddenly when you touch a metal surface, you get a shock, electric shock, and maybe it's somehow similar to a spacecraft flying around Earth. It gets charged, and if it's charged, it is troublesome to some measurements, especially for particles at low energy. They are deflected by electric fields created by this charging, and our instrument produces charges that compensate the original charges. So after all, it is balanced, and the spacecraft is neutral, and it allows particle instruments to make good measurements. It's a long story. Back in the early 70s, I was studying electrical engineering, and I was looking for a thesis, for a master thesis, and it happened that one professor at the institute was involved in space research and offered me to work on writing software to interpret data from rockets sounding rockets in the ionosphere, and I took on this thesis. And then it happened that this institute is the biggest one in Austria involved in space research, and so I moved from one project to the next, and I got the chance to work on the cluster project, where we had a very similar instrument as we have now on MMS. And well, one step after the other, and so I got involved in MMS because MMS wanted to kind of do things better than cluster, and so I got involved in MMS. It's an extremely interesting field. You get a mixture. You have technical challenges, you have good physics to problems to solve. So it's a good mixture of all fields. And if you are working hard and learn early so that you can have the tools ready to allow you to kind of have some spare time for really interesting thoughts and don't have to think about how to calculate something. And then I think space physics is really extremely interesting. And if you are good in mathematics and good in physics, you have a good chance to succeed.